All right, let's practice this. Now we've been doing the parts of a parabola the last week or so. But here's another problem. So make sure you have this paper and the other worksheet for later. All right. So we have an equation here, y equals x minus 4 and then x plus 10. To make this easy, we'll go into Desmos. Put the equation in. So open up Desmos, x minus 4, x plus 10. And then what we're looking for is the 4 points. So we'll make this kind of small. So we got one here, it's the vertex. One here, y-intercept. Then we got 2 here. And we're going to use these 4 points to solve this problem. So go back to your worksheet. And we're going to go back. We're going to toggle back and forth. So the vertex here is -3 and -49. This was the vertex right here. I'm going to write -3, -49. Next is the axis of symmetry. Remember now, the x on the vertex is the axis of symmetry that cuts the parabola in half. Now we have to decide if this is a minimum or a maximum graph. Let's go here. Now remember, the minimum graph goes in a U. Okay? Maximum graph goes in like an N. So this is a minimum. Circle that. And the minimum is the y of the vertex. Oh, minimum. Shoot. Next, we'll look at the y-intercept, which is this one, 0 and 40. Whatever lies on this x-axis, whenever it crosses it, 0 and -40. 0. Okay. Domain. Now remember now, domain is from left to right. So starting here, right, the domain. Oops. You're starting here and you're going to the right. And what we notice here is that it goes on forever. See how it goes on forever? So we're going to put all real numbers. All real numbers are. And then the range is from bottom to top. So the bottom here is -49, and it goes top forever. The way we write that is y is greater than -49. All right, and that's how you do the bell ringer. Let's go to the next worksheet. So press pause, go to the next worksheet. All right, so we're going to be learning transformations on the quadratic function. Remember now, quadratics look like this. It goes like this. Hold on. There we go. So quadratics go like this. Okay. All right. Now the first one we're going to work with is this one right here, this x squared. This is known as the parent function. So you're going to write parent function here. Oh, just write parent. Man, make this larger. Hold on. So we're going to write parent and function. And for this one, the vertex is always at 0, 0. That's why it's the parent function. Okay, or we can say the axis of symmetry is 0, 0. Let's call it axis of symmetry as 0, 0. All right, try right in the box. And then the domain here will be y is greater less than 0. Okay, because it starts right here. You work your way up. All right, so now we have a couple of transformations here. Let's go to this one. So the first one, if you see this negative, so if the front is negative, it's going to look like this. So you get the parent function, and if you reflect it, so we're going to call this the reflection. It reflects over the x-axis. So if you look here, it reflects over the x-axis. Now, for the range, so the range is going to be y, and it's going to be the opposite, like this one. You see how this is different from this one? You flipped it. So you're just flipping that sign. All right, a couple more here. Now here's a basic transformation where we're going to go up 2. So that's the key right there. So f of x plus 2, you're going to go up 2 like this, and the vertex will be here, 2. And it's called a vertical transformation, okay, because you're going up. Vertical transformation. And then just formation. And what it's going to look like is the vertex is going to be um 0, 2, right? 0, 2 because on the y-axis. And then try find some room here. You're going to put the range is going to be y is greater or less than 2. Like that. Now, what if there is a 2 in front of the f? All right, and then this is called a vertical compression. Vertical compression. And then it's by a factor of 2 because 2 is here, right? So a factor of 2 of 2. And then when you put it on the graph here, it's going to be skinny. A little skinny here. Put the dots here like that. Oh, it actually goes down to this and then goes that. All right, let's do the next 4 here. Now, if you see this is the opposite here. Well, not really so much opposite. If you see f of x is negative 2, what you're going to do is put it on the negative 2. So it's going to look a little wider here. Oh, I didn't do it that good. It actually keeps the same like that. Oh my gosh. All right, and then this is called another vertical transformation. But the vertex will be at 0, negative 2. like that. And of course the range is y and -2. Okay. Let's skip this one. We're not going to see the compressions too much. I want to do the ones that we do see. Now, what if it looks like this with the parentheses, x plus 2 . So what this is going to look like, it's another transformation. So, but it's a horizontal transformation. So HOR horizontal transformation, where you're going to go 2 to the left. And this is going to be tricky because you think it's x plus 2, you have to go to the right, but it's actually the opposite. So what it's going to look like on the vertex is -2 and 0, like that. And find the 2 here, like that. And then you're going to go like that. So something like that. Oh, let's just cross these on out. All right, last one. Now, what if you see this one? So this is the opposite. So you're going to write on this one, right? Same thing, but you're going to the vertex is going to look like this. Vertex is 2, 0. Okay, so we'll go 2 here, 1, 1, 2, right there. All right, that's all the notes. Make sure you have these notes. If you missed any, go back to it. All right, I'll see you guys. I don't know when I'm going to see you guys. Oh, yeah, probably language arts. All right, bye.